You can get this opcode sheet from the link given in the description. In the first question, we have to shift 8-bit data 4 times right. Data is in register C. Here we have the number 30 in register C. I will first copy this number into accumulator, as this operation can only be performed in that register. Now I have to use the rotate right instruction 4 times so that the number will get shifted 4 times right. Using halt instruction to end the program. You can also copy this number back into the register C. We have successfully shifted the 8-bit number 4 times right. In the second question, we have to shift a 16-bit number 1 bit left. The number is stored in register pair HL. As 8085 is a 8-bit microprocessor, we cannot perform operations on 16-bit numbers directly. We have to use another technique to do this task. Let's see how. If we have a 16-bit number 3002, after shifting 1 bit left, the number we get is 6004. If we add the number 3002 to itself, we get the same number. This means we can add a 16-bit number to itself and get the number shifted 1 bit left. Now we have to perform 16-bit addition in the microprocessor 8085. To do this, the first 16-bit number must be stored in the register pair HL. If we have the second number in register pair BC, we can use the instruction DADB. This instruction will perform the addition of the numbers in register pair HL and BC. After that it will store the result in register pair HL. Similarly, the instruction DAD will perform addition of HL and D. But we have to add the number to itself. So, we will use the instruction DAD-H. It will perform the addition of HL with HL and store the result in again HL. Let's do this using program. Our number is already in register pair HL, so we will simply use the instruction DAD-H and end the program. That's it. We have successfully shifted a 16-bit number 1 bit left. In the third question, we have to alter the contents of the flag register. The combination of accumulator and flag register is known as PSW, Program Status Word. The important thing here is that this register pair can only be accessed using push and pop instructions. So, if you are not familiar with these instructions, you can check out the video in the I button. To first use the instruction push, I will load the memory address of the stack, that is 8000H in the register SP, stack pointer. Now I can push the contents of accumulator and flag register in the stack, using instruction push PSW. After this, I will pop this content from the stack into register pair HL. I will load the number 0 in the register L, as it has the content of the flag register. After changing the number inside register L, I will push the contents of register pair HL into the stack. And finally, pop the data from the stack into the pair of accumulator and flag register. Ending the program using instruction halt. We have successfully cleared, that is altered the contents of the flag register. In the fourth question, we have to count the number of ones in the contents of register D and store the count in register B. For the explanation, we have changed the registers given in the question. We have the number stored in register B. We will be storing the count in register C and using register D as a counter for the loop. As there are 8 bits in a number stored at register B, I have loaded the number 08 in register D. After checking each bit, we will decrement this number by 1 and will follow this process till it reaches 0. I have also loaded the number 00H in register C. While checking each bit, if that bit is 1, then we will increment this number by 1. We will be using the carry flag to check whether the bit is 0 or 1. And finally, to transfer each bit in carry flag, we will first load the number in accumulator and shift this number 8 times left using loop through carry flag. Let's see how it will work. The number is now being shifted 1 bit left. As the number is shifted 1 bit left one time, the number in register D should be decremented by 1. The bit inside the carry flag is 1, therefore, increment the number in register C. Now the number is being shifted 1 bit left again. Again decrement the number stored in register D. The bit inside carry flag is not 1, therefore, do nothing. After doing these steps 8 times, we will have the number 00 in register D and 04 in register C. This is the count of ones. Now it's time to do it with the program. This is the number we have in register B. First, we will copy this number into accumulator. I will also load the number 08 in register D and 00 in register C. Now I will use the instruction RLC to shift the number 1 bit left. I have marked this instruction as loop. After shifting 1 bit left, I will check whether it is 0 or not. To check this, we have an instruction, JNC, jump if no carry, means jump if carry is 0. A 16-bit address is to be provided for this instruction. We will do this after the next instructions. We are jumping to the next instruction if the carry is 0. If the carry is 1, we are not jumping anywhere. So, we will increment the number of register C. Now we have to decrement the number of register D as we have completed one iteration of the loop. The address of this instruction is to be provided to the jump instruction used above. This means, if the carry is 0, the increment instruction will be skipped, and if carry is 1, the increment instruction will be executed. Now the number in register D is 7, which means we have to do this task 7 times again. So, I will use an instruction JNZ, jump if not 0. After decrementing the register D, the 0 flag will be set to 1 if the number in D is 0. So while it is not 0, we will jump to the above RLC instruction where I had put the loop mark. When the number in the register D becomes 0, it will not jump on the RLC instruction. Instead, it will end its execution using halt instruction. After execution of this loop, we will get the count of 1 stored in register C. If this video has helped you, please show your support by liking the video, share this knowledge with others and subscribe to the channel. Thank you.